Hi everyone, I hope you're keeping well. We're going to have a look at this week's homework question, which is week 3. This is the ordinary level one. It's from 2017, question 6, and it's still mechanics based. That's the area we're kind of working on at the moment. All right, let's have a go. Let's get cracking. Remember, you can cast your eye over your notes before trying these questions, okay? You can study them, go over the material, check out the video from the previous week. The ordinary level video solutions here are chiming in at about 10 or 12 minutes, so it's very much worth the time to look at and kind of usually pays off. Now, that being said, it's time to study and doing the work, so no substitute for that. Let's just get cracking. Let's give it a go. All right, so we got a fairground slingshot is shown below. Springs attached to the pod are used to store a form of potential energy. When the pod and springs are released, this potential energy is used to exert a force, which gives the pod an upward acceleration. At the pod's highest point, the occupants experience apparent weightlessness for a short time before gravity causes the pod to fall back towards the ground. Okay. The first part of the question, explain the underlying terms. Each of these has 6 points going for it. So let's talk about force first. Force is anything that causes an object to accelerate or change velocity. Something that causes an object or a body to accelerate. And that could be getting faster, or it could actually be decelerating as well. They kind of mean the same thing in physics. So acceleration could be just in one direction or another. So it's going to cause something to either start increasing its velocity or decreasing its velocity, including changing direction. So force is anything that causes an object to accelerate. 6 marks for that. Speaking of acceleration, I probably just went into that there. What is acceleration? Acceleration is a change in velocity over time. Straightforward enough. For gravity, now this is a bit trickier at times because it's a force of attraction between all objects. Most people just think about it in terms of Earth's gravity. Remember, anything that mass has gravity, and gravity is the force of attraction between all things that have mass. Okay, the more mass something has, the stronger the gravity force of attraction between two objects, or the closer they are. Lots of crude jokes to be made here, but let's keep cracking on. All right, so there are three definitions, 6 points each, 18 to be got for them. Now remember, these are all in your notes, all worth just spending a bit of time having a look at before you try these. Quite handy once you've done that. All right, what form of energy does the pod have due to its motion? Whenever anything's moving, it's kinetic energy. That's part II. That's part I up there. Part 3. What form of energy does the pod have at its highest point? Gravitational potential energy. Because it has the potential to lose energy when it falls down from its position, or it has the potential to gain more if it went higher up. So it's stored energy, it's gravitational potential. That's the part 3. Why do the occupants experience apparent weightlessness at the pod's highest point? Well, at the pod's highest point, gravity is still pulling it down, but there's no reaction force pressing against it. So they're in free fall. They're falling at the same velocity as the pod itself. So if you're moving in the same velocity as something beside you, it seems that you're weightless, that you're just kind of rolling along with it. So the reason for the apparent weightlessness is that there's no reaction force. There's no normal force between. Sometimes we call it upthrust, but there's no force other than gravity, just gravity. That means that they are in free fall. Okay, that's part IV. I think they want us to do a little bit of calculation for part V. Excuse me, the mass of the pod is 400 kgs. Let's just write that in. It's probably going to be useful in a minute. It reaches a maximum height of 50 meters above its point of release. Calculate the potential energy stored in the springs before the pod is released. Now, it might have thrown you a little bit how to go about this, but you got to remember that the energy stored in the springs is going to cause the pod to go up. So the energy that the pod gains in gravitational potential came from the energy that's in these springs. So essentially, they're the same value. So the tension in the springs is equal to the gravitational potential energy that the pod's going to get. has to come from somewhere. Remember, you can't create or destroy energy. We're only converting it from one form to another. So it's being converted from tension in the springs, potential energy in the springs, to gravitational potential because the pod is thrown upwards. So what is that value? Well, the energy is equal to the gravitational potential, which is mgh, because remember the potential energy is equal to the the potential energy in the springs is equal to the gravitational potential energy that the pod gets. Sorry, I'm losing the thread a little bit here, guys, a bit tired, which is mass times the acceleration of gravity times the height. Now, many of you guys were on the right track, you just forgot to multiply it by g. That's an important one, you've got to include it. So the mass is 400, the acceleration due to gravity is 9.8 meters per second squared, and the height is 50 meters. I'll leave out units for now, but you've got to make sure you put your unit in at the end. It doesn't really matter too much if you leave it out in the calculation itself, as long as you give it in the end, or at the end. And for energy, it's always going to be joules. So it's going to be 400 times 9.8 times the height is 50. That's 196,000 joules. So 196,000 joules. That's the the potential energy that was stored in the springs. Okay, draw a diagram to show the forces acting on the pod when it is released. Okay, so we've got easy enough diagram. They don't have to be massive. We've got the pod. We have its weight. And we have tension, or the tension that was in the springs, which is going to cause it to go flying upward. So that's the, just a quick note here, sorry, my phone just vibrated and buzzed. It could have distracted me a little bit. So the force of gravity here is less than the energy and the tension, which is why it accelerates upward at first. So we represent that by having the tension arrow being bigger than the weight arrow. So that's part VI. 6 marks going for that one again, 6 for the previous calculation. Calculate the momentum of the pod when it has a speed of 8 meters per second. Okay, so the velocity here is 8 meters per second. The pod has a mass of 400 kgs, and momentum is mass times velocity. So it's 400 times 8 kgs, so it's 3,200. Let's just verify. Yeah, 3,200, and we'll talk about units in a moment. Now, the unit for momentum, because you're multiplying mass by velocity, you multiply the units too. So it's kilogram times meter per second. So the unit for momentum is kilogram meters per second. Okay, the very, very final part, VII, is state one energy loss that might prevent the pod from reaching its maximum height. That's going to be air resistance. It's going to slow it down a little bit. Okay, and that's everything for that question. So you might notice the first section is always quite nice. It's usually kind of list a couple of definitions, and then you have to get into some calculations. Just keep in your head what's going on. A lot of the time, it's either going to be SUVAT stuff, calculate using the standard motion equations, or it will be one of these where you're converting energy from one type to another. It's usually, but not always, going to be gravitational potential and kinetic, or something like that. It can vary, but it's always going to be one energy equals another, and then you might do a little bit of work there. But as I say, guys, keep the questions coming. If you're not sure about something, ask. This is all material you haven't really looked at too much since 5th year, so you're going to be rusty on it at first, but hopefully it's starting to click now. Use the notes, use the previous videos, use anything and everything at your disposal, and let me know if there's any issues. Okay, take it easy. Talk to you soon. Bye-bye.